Welcome to Pathan Sir Chemistry YouTube channel. If you have not yet subscribed it, subscribe my channel. Now today you will learn unit solid state. In that point is X-ray diffraction and crystal structure. Particularly the topic is Bragg's equation. Now let us go for the derivation and understanding of Bragg's equation. For that, let us consider a metallic crystal, different planes made up from atoms, metallic atoms, and this diagram shows two different metallic layers, the first layer, the second layer. Okay, then the X-ray, which is shown in red here, this one, is incident on a metallic crystal whose wavelength is lambda and its incident angle is theta. This one, glancing angle or incident angle is theta. Remember, this angle and both these angles are same. Okay. So Bragg's equation was actually derived by father-son W.L. Bragg and W.H. Bragg in the year 1913, and they showed that number one, the X-ray diffracted from atoms in a crystal plane obeys law of reflection. That means X-ray when incident on a metal surface will be reflected just like glass reflect. And number two, the second beam of X-ray, it will be in phase if the extra distance traveled by the X-ray is an integral multiple of lambda, that is n lambda. Extra distance traveled means this is the first ray, this one is a second ray. Now first ray is coming up to this point and reflecting, then the second ray is coming up to same point or equivalent point at this, then the second ray is traveling extra distance from CB to BD. So this extra distance, that is CB plus BD, traveled by the second wave should be equals to n lambda when they are in phase. That means if they make constructive interference. That is the observations made by the W.L. Bragg and W.H. Bragg. Okay, on the basis of this we can find out the interplanar distance between two atomic layers. This is first layer, this one is second layer. You can find out interplanar distance, that is D, using these two observations. Remember here, this is AB, this distance AB and D is same. That means we want to find out the distance AB using wavelength lambda and angle of incidence theta. Now, as we have seen, when X-ray is in phase, then extra distance traveled by it or second wave, that is CB plus CD, should be equals to n lambda. Okay, now let us make one point perpendicular from A to C on second wave and AD from on second wave. Okay, now it make triangle ABC and triangle ABD. Remember, this theta and this theta is having same value. Okay, now let us consider triangle ABC. Now triangle, in case of triangle ABC, sine theta is equals to BC divided by ABC. Okay, then therefore BC is equals to AB sin theta. We just transfer this AB from this side to that side. Now consider second triangle, that is triangle ABD. So in triangle AB and D, again sin theta is equals to BD upon AB. Therefore BD is equals to AB sin theta. Now we got the value of BC and BD here. Now we'll substitute the value of BC and BD into that equation. Therefore we get n lambda is equals to AB sin theta plus AB sin theta. Therefore, it is AB sin theta plus AB sin theta means n lambda is equals to 2 times AB sin theta. Okay. Now this distance AB is equals to distance D. Therefore, instead of AB here, we can write D. Then equation becomes n lambda is equals to 2D sin theta. This equation is called as Bragg's equation. So n lambda is equals to 2D sin theta is called as a Bragg's equation, where n is an integer having different values starting from 1, 2, 3, 4 and so on. If you put value of n as 1, then the equation becomes lambda is equals to 2D sin theta. So this equation is called as the first order Bragg's equation. Then if you put n is equals to 2, then this equation is called as the second order Bragg's equation. If you put n is equals to 3, then that becomes third order Bragg's equation. If you put n is equals to 4, then fourth order Bragg's equation and so on. Thus, that is Bragg's equation. Thanks for watching. Subscribe this channel and like, share to your friends, and if you have any problem, comment. Okay, so we'll stop here. Thank you.